Hey guys, so I'm back again with another video, and today we're going to be talking about trigonometric identities once again. So right now I'm just doing a brief overview of some of the identities we learned last week. So as you can see here, these are some reciprocal identities, and they work both ways. Like I mentioned before, tangent of theta is obviously going to equal 1 over the cotangent of theta. Same with cosecant and sine, and secant and cosine. Then we have our quotient identities here, and here you can see I demonstrated how you can flip those around. So tangent of theta equals sine of theta over cosine of theta. Then the cosine of theta would equal sine of theta over tangent of theta. Here are the Pythagorean identities. And as you can see, ignore that even odd thing. As you can see, we talked about how theta can represent anything from an angle to a real number or a variable in a problem, and I demonstrated that with an example I did in my last video. Okay, so by the time we're learning about trigonometric identities, you should already have your unit circle memorized. So we're not going to get into that, but some of the problems I'll be showing you today, you will need to memorize your unit circle to be able to do that. So just remember that, guys. So here are some of the equations. I already went over these few. Here are some even and odd identities. And cosine and secant are always going to be even. The rest are odd, as you can see here. These are the cofunction identities. I did not demonstrate these last week. Here are the sum and difference formulas. Now, personally, I like these the most because I feel like they're the easiest to handle and work with. And so as you can see here, the sine of A plus B is going to equal the sine of A times the cosine of B plus the sine of B times the cosine of A. And it's going to work like that. A trick I used to memorize it was, especially for the cosine ones, I would say if there's a plus in here, there's going to be a minus in here. And then for the sine ones, I would just remember that it'd be the same. But yeah, that would be a tip I would use to help memorize those. And here are the tangent sum and difference formulas. And I would kind of use the same thing here. If there's a plus here, there's going to be a minus there. If there's a minus there, there's going to be a plus here. Then, since we're already here, let me just show you these power-reducing identities. So the sine of theta squared is going to equal 1 minus the cosine of 2 theta divided by 2. The double angle identities, half angle identities, which are not my favorite at all, but still gotta know them. The product to sum identities, and the sum to product identities. Personally, the half angle identities were the hardest for me to memorize. Now, I know I said I wasn't going to get too into the whole unit circle thing since you should already have it memorized by now, but I'm just going to give you a brief overview of some of the main angles you should know. You definitely need to know 30, 45, and 60 by now, and memorizing these three and the angles that meet at every quarter, so like 0, 90, 180, and 270 is kind of going to be your basis to remembering all of them. And that's kind of the trick I used. And also, as you can see here in these ordered pairs, the cosine is going to be x and then the sine is going to be y. So that's something I used to really memorize it. And then obviously you need to know which signs are negative and which signs are positive and which quadrants. That's another key thing. So this is also something I used to memorize the unit circle. Okay guys, so now we're going to do some example problems. So right now we're looking for something that's going to give us the answer to, obviously, we want to know what goes in the blank. So if you memorize your identities, you should remember that the tan of x is equivalent to the sine of x over the cosine of x. Something I use to memorize this is I would say that tansin over cosin. That sounds kind of cringy, but tansin like dancing over kissin. and cosine, you know, tansin over cosine. That's something I used to remember, it dancing over kissing. But yeah, that's something I used to memorize. If you really work your way around things, you can find little things like that will help you to memorize certain functions and identities, and yeah. So if the tangent of x is equal to the sine of x over the cosine of x, we want to get sine of x on the left side, or we want to get sine of x alone, like it is here. So to do that, we would have to multiply cosine of x out here, cross that out, then we would have the tangent of x times the cosine of x is equal to the sine of x. And here we have the sine of x equals blank times the cosine of x. And we know that it's going to be tangent. So tangent is our answer for this problem. Okay guys, so for this next problem, we're going to want to find the exact value of this equation. So we're wanting to find the exact value of the sine of 75 degrees. So to do that, we are going to be utilizing one of our formulas. Can you guess which formula we're going to be using? You're correct. We are using a sum and difference formula, specifically a sum and difference formula of sine. So the formula we're going to be using is going to be, there you go, you see my equation there. What we're looking for is a number that we can, two numbers that we can use to divide 75 into an A and a B. So, thinking back to our unit circle, what numbers do we know that we can utilize to get the exact values of the sine of, say, 75? Right off the bat, I immediately think of 30 and 45, because remember what I said. Remembering those first three angles, 30, 45, and 60, along with 0, 90, 180, and 270 degrees, is going to help us memorize all the other angles in our unit circle. So right off the bat, I think of 45 and 30, which are equivalent to 75 when it's added together. So the sine of 30 plus the sine of 45 degrees. And in our equation, that's going to look like this. Sine of 30 degrees times the cosine of 45 degrees plus the sine of 45 degrees times the cosine of 30 degrees. So here's what our problem should look like now. So right off the bat, if you memorized it correctly, you should know that the sine of 30 degrees is equivalent to 1/2. And whatever the value of the cosine of 45 is, we're going to be multiplying it by the sine of 30. So just remember that. Always include that multiplication sign, just so you don't forget. So the cosine of 45 degrees is square root of 2 over 2 plus the sine of 45 degrees, which is also square root of 2 over 2, times the cosine of 30 degrees, which is going to be the square root of 3 over 2. So, first thing we want to do is multiply both sides of the plus sign before we add it all together. Using PEMDAS, we know that we need to multiply before we add. So what's 1/2 times the square root of 2 over 2? It's going to be the square root of 2 over 4. And what's the square root of 2 over 2 times the square root of 3 over 2? That's going to be the square root of 6 over 4. When you add the square root of 2 over 4 plus the square root of 6 over 4, you get square root of 2 plus the square root of 6 over common denominator of 4. So our final answer is just going to be the square root of 2 plus the square root of 6 over 4. Hey guys, so for this final problem I'm going to show you, we are going to use the sine of theta equals 2/3 in quadrant 2. And using that, And using that, we're going to find the values of all the 6 trigonometric functions. Like I said, we already know that the sine of theta is going to equal 2/3, because obviously that's what our problem tells us. And the first thing you have to remember is quadrant 2. Why is the problem telling us that sine of 2/3, the sine of theta is equal to 2/3 is in quadrant 2? Why is that relevant? We have to remember and recall that in quadrant 2, some values are going to be negatives and some values are going to be positives. Now, the way I remember it is I try to remember which ones are positive rather than the negatives, because there's more negatives than positives in each quadrant. So, in the first quadrant, we know that everything is positive. In the second quadrant, we know that sine and cosecant are going to be positive. In the third quadrant, we know that tangent and cotangent are going to be positive, and in the fourth quadrant we know that cosine and secant are going to be positive. So I just remember it by, as long as I remember sine, cosine, and tangent, and I remember their opposites, that's pretty much how I memorize which ones are positive and which ones are negative in the graph. So since the sine of 2/3, since the sine of theta is equal to 2/3, we know that from our reciprocal identities, the cosecant of theta is going to equal 1 over the sine of theta. So let's do it in pencil here. 1 divided by 2/3 is going to be 1 times 3/2, which comes out to 3/2. Simple. So we know that the cosecant of theta is 3/2. Now, to find the cosine is going to be a little bit trickier, which is why we're going to start out with something else first. So now we know 3 values, or now we know 2 values. We know our sine and our cosecant. So remember how in the last video I would talk about when we're looking for a certain trigonometric value, we have to utilize identities that involve those values? So looking at our cheat sheet here, we're going to find an equation that utilizes both sine and cosecant, or something that can help us to find any one of these functions. So, looking around, I notice in our Pythagorean identities, we have the cosecant squared of theta equals 1 plus the cotangent squared of theta. So, I'm going to write it out here. The cosecant squared of theta is equivalent to 1 plus the cotangent squared of theta. So, we know that cosecant is 3/2, so we're already going to put that in there. So that's going to be 3/2 squared equals 1 plus cotangent squared of theta. We solve that. That's going to be 9/4 equals, we're going to subtract the 1 from there. So -1 plus 9/4. When we put that on the same denominator, we're going to get 9/4 minus 4/4, which is going to equal 5/4. So 5/4 equals cotangent squared of theta. Now we have to find the square root of both sides. So the square root of cotangent theta, so the square root of cotangent squared of theta is going to equal cotangent of theta. This is going to be the square root of 5/2. But you have to remember that we're looking for the value of the cotangent of theta in quadrant 2. So in quadrant 2, the cotangent of theta is going to be negative because only sine and its reciprocal cosecant are going to be positive in quadrant 2. So the answer is going to be, and using this, we can find tangent now because with our reciprocal identity, we know that the tangent of theta is equivalent to 1 over the cotangent of theta, which means that the tangent of theta, sorry about that, is going to be 1 over negative square root of 5 over 2. That's going to bring us here to 1 times its reciprocal, 2 over. It is going to remain negative because, like I said, only sine and its reciprocal cosecant are positive in quadrant 2. So tangent equals negative 2 times the square root of 5 over 5. Now to find cosine and secant, which look as though they have been left alone this entire time. But if we remember our trigonometric identities, we're looking for something that can help us to find cosine and secant utilizing the values we already have. So right here, I can see that in my quotient identities, we can utilize the cotangent of theta is equivalent to the cosine of theta over sine of theta. And we can use that to find cotangent or tangent. We can utilize either one of these equations. So I'm going to make it easier on myself. So I'm going to use the cotangent one. So I'm going to work a little off to the side here. So cotangent of theta equals the cosine of theta over sine of theta. And the cosine of theta, we don't know, but we know the cotangent and we know the sine. So negative square root of 5 over 2 is going to equal the cosine of theta over 2/3. Multiply 2/3 out, cross that out, times 2/3 plus 2, negative 2 times the square root of 5 over 6, which is going to simplify to negative square root of 5 over 3. And that's going to be equal to cosine of theta. Now, using the reciprocal identity once more, we can find the value of the secant of theta. So I'm going to go all the way up here. Secant of theta is equivalent to 1 over the cosine of theta. So 1 over negative square root of 5 over 3 is going to equal 1 times 3 divided by negative square root of 5, which is going to give us 3 over negative square root of 5. Then we have to rationalize it. Oh gosh, I'm so sorry I didn't get that in the frame correctly. Times square root of 5. We have to rationalize the denominator because we can't leave a square root in the denominator. So that's going to give us negative 3 times the square root of 5 over 5. And that's our final answer, and that is the value of secant. So secant is going to be negative 3 times the square root of 5 over 5. And that's how we were quickly able, using all these different functions and utilizing our trigonometric identity. So just like that, we were able to find the values of all 6 trigonometric functions, just utilizing the value of sine and knowing that it's in quadrant 2. So it's kind of crazy how just by knowing 2 things, just by knowing a value and its location, we're able to find all of these. That's kind of a wow factor. Pre-cal is crazy like that. So moral of the story is you are going to have to get deep and personal with these trigonometric identities, and you are going to have to know every bit of them. So thank you guys so much for watching this video. I hope you enjoyed, and see you later.